right? Then we move towards diversity indices. Diversity indices are the quantitative measures which are required to get the idea of richness, divergence, evenness, dominance, abundance as well. Okay. So two most used diversity indices are Shenan-Wiener index and Simpson's diversity index. Now Shenan-Wiener index usually talks about about rarity. Okay, so the idea behind Shenan-Wiener index comes from a mathematical observation. Both of them are actually mathematical observations, where one talks about entropy. So Shenan-Wiener index basically was based upon mathematical system which talks about entropy in a system. That is mean disturbances. So that's why a minus symbol has been added to identify more the abundance or evenness. So Shenan-Wiener index, where H stands for the Wiener index, and Pi stands for the proportion of the particular individual. Now we will do problems, so it will get an idea. But and ln is the natural logarithm. So focus on ln, not log. Okay. So Shenan-Wiener index works around ln, and log has a bit of difference in the value. So usually we should use ln, not log. Okay. So S talks about the number of species in the community. Okay, and apart from that, as we have talked, the Shenan-Wiener index talks about evenness. Okay, evenness of the particular region. So how evenly they are distributed. More the amount of Shenan-Wiener index, more the value, more even they are, more equally distributed they are. Right. So from a Shenan-Wiener index, we'll get the idea of equal distribution or evenness. Right. So you should remember these factors while taking out indices. Now in Simpson Index, I have provided 4 formulas. Now the thing is, Simpson Index is a little bit confusing in the sense all of these are correct formulas. Okay, so you might find different systems in which different formulas are mentioned, but it is different and all three are the same. These three are same. Okay, so you don't need to worry about the different looking formulas, but these three actually give out similar values. So this is proportion which is similar. So these two are equal. These two are the same thing. Little bit different this one is, but it actually gives similar amount of values. So whenever if you actually apply that, you can get similar amount of values. But the thing is, this is more simple and you should apply that in your exams as well. And you will get that sort of value only. You will not get value way different. So there will be differences of 0.0, 0.4 or 0.0.5, like these kind of differences that you will get only among value of this and this. You will get the same value between these. Okay, so you don't need to worry much about which formula you're applying, but these are most accepted one. Now the good thing about GATE is they actually give out which kind of formula they will be applying to. So this one will be different and this one is different. Now the thing is, I couldn't find the actual differences, but it is mathematical in the sense, and it talks about abundance with respect to differences. Okay, so it is mostly that talks about abundance. Simpson diversity index is based upon abundance and dominance. Okay, it talks about abundance and dominance. Now this formula can be actually used for comparisons. Now this is easy and most used formula as well. Now sometimes this is used, sometimes that is used. So in case if it is not given which formula to use, so be cautious on which one you is choosing. But sometimes or most of the times in GATE actually they give out which formula they are applying to, but in NET sometimes they don't. So but in NET the good thing is they'll give out multiple choices. So whenever you're doing that, when you are applying these formulas, make sure that the value that comes out either is around this one or around this one. Now the thing is, when you try out this formula, the value will come above 1. If you're trying this formula, the value will never come out of 1. So this indices, these formulas actually give out value between 0 to 1, where 0 talks about no diversity, whereas 1 talks about infinite diversity. Okay, so the values usually around 0 to 1, but these values can go way beyond 0. and 1. Okay, so they might come as 5 or 6 or 7 or whatever depending on the particular diversities, but this one comes usually within 0 to 1, and both of them mean that the higher the number is, more abundant they are. Okay, here the same thing. PI talks about number of individuals with respect to the total individual, that is proportion. Proportion always talks about, is the number of, let's say, ni by n, that is number of individuals with respect to the total number of individuals. So let's say if I'm talking about proportion, like, so let's say there are 50 individuals, there are 30 individuals, and there are 20 individuals. Okay, so of each species, species A, species B, and species C, so there are this much of individuals. Now the total number of individuals in the entire area is 100, right? So you have to take out proportions. Proportions here will refer to 50 by 100, 30 by 100, and 20 by 100. So each proportion, sorry, 20 by 100. So each proportion that we are getting is this much. Okay, that is proportional. But we'll do the problems and we'll get a basic idea as well. But take in account that n talks about total individuals and n small n talks about number of individuals. It could be either ni or it could be n. Okay, sometimes this one is given as ni, sometimes this one is given as n, so it varies as well. You don't need to worry about it, but the basic idea revolves around these particular factors. Okay. Now the thing that is left is Shenan's Equitability Index, which also talks about equal evenness or evenness. That also gives about the idea of equitability. I mean, how they are equally present. Okay, so sometimes this is also utilized, so you can use this one as well. Whereas H is the Shenan index that you will first need to find out. Then you can utilize that by providing dividing that with ln S. So we'll move forward to questions, so we'll get an idea. So this question was from GATE 2014, and here you can see clearly that is given that it is given that it is d. So here it is clearly given that d equals to 1 by summation of pi square. So how do you need to solve it? So first what we need to do is we need to prepare a table as well. Okay, so Q R S T U V. Now we'll do all the problems with diversity indices with respect to tables. Okay, so here the n, remember pi refers to ni by n. Yeah, okay, so here n equals to how much? If you count it, it will get 200. If you count it total, you will get 200. So you have to count what is ni. Ni here is given as 50, 30, 20, 40, 50, and 10. Whereas the ni by n will give you how much? 50 by 200, 30 by 200, 20 by 200, 40 by 200, and so on. So we have to take out it as decimal values. Okay, it will come out as 0.25, it will come out as 0.15, it will come out as 0.1, it will come out as 0.2, it will come out 0.25, 0.05. Okay, so now you got the values. This is of ni by n. Okay, so these are values for ni by n. We need to take out decimal values. Now the next thing is, which is also pi. Okay, so it is, so pi equals to same thing. Now the thing is we need to do is pi square. Now pi square will be 0.0625, 0.0225. So this will be 0.01, and this will be 0.04, right? And this will be 0.0625 again, and this will be 0.0025. So if we add it up, okay, if we add it up, let's say, so we'll get summation of pi square. Okay, if we'll add all that up, we'll get summation of pi square. So we'll add it up, we'll actually get 0.2. If we add everything, we'll get 0.2. So summation of pi square equals to 0.2. Now when we put that, we'll get d equals to 1 by summation of pi square. So when we put that, we'll get d equals to 1 by summation of pi square, right? So when we put that, we'll get 1 by 0.2, that is 5. So here d equals to 5. Okay. So once you do it, you'll get the hang of it. Now the other fact, now the other formula that is used was d equals to 1 minus pi square. Now it can be same with d equals to summation of n by n square. Okay, because you know that pi equals to n by n, or it can be also written as ni by n. Okay, so these two things are same, but this one, the other one, 1 minus n by n into n by n minus n into n. So this one, this entire thing is somewhat same to it because it gives out similar values. Okay, so it won't be entirely different, it will give out similar values, so do not to worry about it, but you need to apply this one because it is more simple and it should be more utilized. Okay, because this one will give you, no, more time, it will take more time to solve out. Anyways, coming back to this question, now here it is already given, we have ni, so ni is already given. Now the thing is we need to find out pi, that is ni by n. So the n here is how much? N here is again 200. So ni by n equals to 140 by 200, 50 by 200, 2 by 200, which is similar. So here you can actually see that one species is pretty dominant, other species are pretty rare. So you can see the diversity index will come out pretty low. It should come out low, right? So you'll get an idea about that. Anyways, we'll move forward and do this, where we'll get the value is how much? 0.7. Okay, and here it is 0.25. Here it is 0.01, and so on. Okay, now the thing is, this one is pi. We need to find pi square. Okay, so 0.49 and 0.0625. This will come out as 0.00001. Okay, again 0.0001, again 0.0001. Right? If we add this up, then you'll get how much? You'll get 0.5530. Okay. Now when we subtract that, so this is summation of pi square. Now we have to subtract it with 1. So here d equals to 1 minus summation of pi square. So we'll get as 0.553. So if to get round off to 3 decimals, so what we'll get is 0.447. So this is the answer. Okay, so this is how we'll do it. We'll always count that with respect to ni by n. We'll take out pi, we'll take out pi square. So it will be easier and directly taken out. So this question is about Shenan index, right? So we'll again deal with pi. So pi is about, again pi equals to ni by n. So ni is already given, and we have to take an n. We have to take n, that is usually around 100. Okay, so we have to find pi. Pi here will be 5 by 100, so it will be 0.05, and then it will be 0.2, 0.25, and 0.4, right? So the thing is, next we have to find is log pi. Okay, so next thing we have to find is log pi. So the next thing we have to find is log pi. Log pi is, we'll take calculation, we'll take the help of calculator, which will be already given in your gate exam. So I have went forward and taken out the value of logs. So the logs values are as follows. So we'll take 3 decimal digits so that it will be easier, because sometimes 2 decimal digits match as well. So you can 3 or 4, whatever you're taking, but you have to use that. So after we do that, we'll get these values. Okay, so combine that, you will get the value of 0.613, and this is what? Summation of, this is summation of pi log pi. The thing is, the in Shenan index is h equals to minus of summation of pi log pi. So the answer is 0.613. So this is how we'll do Simpson diversity index and Shenan indexes.